I mean, they already got the classes set up for you.
Well, there's,
Was there something else, something I'm missing?
no, so
All
they-
in one of the other ones? So that might be one that we wanna do. Somebody help me out and tell me what the classes were. 20 to 30? 31 to 41.
63, 63, 64, 74, 75, 85, and 86 to 96.
And did they have a tally in there? They didn't, did they? Just had the frequency. First thing, somebody give me a class width here, be careful.
10.
It's 11. How do you find the class width?
subtract the bottom.
Subtract any two consecutive lower limits. So 31 minus 20, 11. Class width is 11. What's the frequency for this first one?
19, 43, 68, 69, 77, 58, 24.
Now, somebody help me out, what were the ones that they added to it in example two? Midpoint. Guarantee this is on the quiz, you're gonna have to find the midpoint of each one. Hardest part on the quiz though is setting up the classes.
20.
How do we find it?
Add them together, divide by
Add them together, divide by two, that's 25. Now, do we wanna keep adding them together and dividing by two? What's an easier way? Add the class width, that's why I found it over here. What was the class width again? So 25 plus 11, plus 11, plus 11, plus 11, plus 11. What else did they have on there?
Relative frequency.
Relative frequency, again, is the percents, right? So first thing we're gonna have to do that is, and I don't know, did they tell us?
I think it's 360.
Grab up your grab your calculators and add those up, what's it come out to be?
I think it's 360.
365,
Yes, it is.
that's what we're going with, 365. Now you're gonna need your calculators out anyway, because to find relative frequency, what we're gonna do is we're gonna take, oops, not that number. We're gonna take this number, the frequency, divide it by that, and then change it to a percent. That's what we're gonna put in here. So for this first one, I'm gonna write it over here, because I didn't leave myself space in there. It's 19 divided by 365, then the second one is gonna be 43 divided by 365, and so on, so on, so on. Round it off to the nearest percent, and we'll go with that. Somebody help me out, what's 19 divided by 365?
0.05.
0.05, so 5%? Is that what you guys tell me? 43 divided by 365.
12%.
12%? 68 divided by 19%. 69, I'm guessing probably 19% again, isn't it? Is it 20? 74 divided by that's 20? 68, we already did, that was 19%. 24, and we didn't do anything like that, 7%. What should all these add up to?
100.
Do they add up to 100? 101, that's pretty close. As long as we're 101, 99, somewhere around that range, it's probably all right. And then the last thing they asked us for was cumulative frequency, is that right? Remember, cumulative frequency, you're just adding up how many, whatever these are, whatever we hear, people, elephants, cows, whatever they are, how many of them are at that point or below? Well, if we're here, how many are at that point or below? 19, that is easy. How many, what do we do to get this next one?
Add them.
Add 'em
25
up.
plus 30.
What's 43 plus 19? Yeah, don't look at the wrong column. What is it?
62.
62, then add another 68 to that, what's that give us?
180.
Then add a 69 to that, 190 what? Add a 74 to that,
273.
add a 68 to that,
341.
341, and the last one better be 365, is it?
Yeah.
Is that all they wanted? Yes, no, maybe? What are we missing here? Boundaries? Class boundaries, we could have done, they didn't ask us to do that.
Yeah, that's for
They asked it for
the previous one.
And another one,
yeah. So-
class boundaries, what do we do to find the class boundaries?
Subtract them from the lower end or half.
Go down a half, go up a half. So for the first one, it'd be what? 19.5 to 30.5, so on, you guys can find it, it's probably right. Nothing really hard about that, we didn't ask for them on this problem, but. Next question. Let's take the quiz, you don't wanna see how to find the classes on any of them?
I just did about each.
Sean just wants all you guys to do, he didn't care about you guys.
Can we just find the classes for 36? We don't have to go.
So I can do all of it,
Yeah.
find the classes.
Did you want her? No? Sorry.
He wants to.
He's a scholar,
He wants to be here and all you guys here, and he's trying to keep you guys down, man.
That's what being in the top 5%.
Yeah. He's got that big head down, he's thinking. The good thing, Sean, about thinking that way, I've always thought this way as a teacher, as I look around the rooms, as I'm teaching a class, I'm thinking, yeah, my sons are gonna be your boss, your boss, your boss, your boss, your boss. When people are not real intelligent, I'm always thinking, hey, that leaves more upper level jobs for my sons. They can take care of me better when I get old and can't take care of myself. Maddie, which one did you say?
36.
36. 36. Give us a big long list. Yeah, it ain't too long. So first thing, on 36, we want to find the class width. That's what you're gonna have to do on the quiz. Somebody help me out, what's the highest number in that list? 80?
Yeah.
Everybody agree with that? Lowest one? Somebody read the problem for us, what did they say, how many classes? 5 is what we're splitting it up into? So 80 minus 10 divided by 5. What's 80 minus 10? 70 divided by 5. Now, I don't like this one because we're supposed to do what? Round up every time. And when you get something even like this, we'll just leave it that way. It might not hurt to round that up to 15, but I'm not sure, so we'll leave it at 14 since it came out perfectly. So that's our class width. Now, when we start our classes, we need the lowest number. You guys already told me that, what was it? So 10 goes right there. Then we find all the lower limits. Then we'll worry about the upper limits. And to find the lower limits, we just add that. So 10 plus 14 is what? And plus another 14, plus another one, plus another one. And we only wanted 5 classes, right? So we should be good there. How do we find the upper class limits?
Subtracting one from
This one, go down one, so that's 23, what's gonna go here? 37, then what? 51, 65, then on this one, the way we have to do it is add the 14 to it to find this last one. 79, the highest one's 80, and that's probably, so let's go back. That's what I was worried about. Instead of 14 here, what are we gonna do with this?
Make it 15.
Round it up. So even if it comes out even, we'll just go with that for the rest of the year. Even if it comes out even like that, round up to the next number. All right? Because we might miss numbers. So now let's go back and let's redo our classes. What's the lowest number? 10, and 25, then what? 40, 55, 70. What's this one gonna be? 24, 39, 54, 69, add a 15 to that, 84. Does that cover them all then? Next thing we would do is our tally. Do we want to go through and do the tally? Are you guys ready for your quiz?
Let's do the tally.
Let's do the tally. So somebody read off the numbers for me.
35, 10, 30, 25, 75, 10,
Alright.
30, 20, 20, 10.
2 20s?
Yes.
10.
40, 50, 40, 30, 60, 70,
60, 70, alright.
25, 40, 10, 60, 20, 80, 40, 25, 20, 10, 20, 25, 30, 50, 80, 20.
That's it?
That's it.
Then we find what? Frequency. How many in this first one? 11, 9, 6, 2. Let's see, that's 10, 21, 32. Was there 32 numbers? Open.
Yes.
Then, if we were gonna go on, we could find the what? The midpoint, relative frequency, so on, so on, so on, all the rest of it. Everybody understand that first part of it? Again, what's gonna happen if you mess up right here? Everything else is gonna be screwed up. Now, might you get lucky and there might still be a 9 here? Yeah, you might get lucky and get a point here, a couple points, but most of it's gonna be messed up. We ready then? On these notes, other graphs, what we're gonna cover today, and we're gonna go extremely quickly because we gotta get this done. So we got, what, 30 minutes? We're gonna get it done. I don't care what happens. Besides histograms, other graphs that we're going to cover, stem and leaf plots, dot plots, time series. We're also going to cover something called a Pareto graph, Pareto chart, so on, so on, so on. There's a whole bunch of them that we're going to cover. And most of it, you just got to be able to read them, know what to do with them. Some of them, there's another one, scatter plot. We're going to cover it too. Some of them you already have seen. Hopefully you've seen a stem and leaf plot before. Scatter plot. And what's the one that goes with the stem? Oh, box and whisker. Fox. I think it's, oh, no, don't do that. We've written a box and whisker. It does.
He broke it.
Doesn't do it very often, or it hasn't for the last couple of years.
Boxing
Alexa, does that sound like it's coming? Does it sound like it's running? Can you hear it? No.
Blue thing on.
The blue's on?
Is it flashing?
No.
This is the thing that takes. That is the thing that takes. It's like an important document.
No,
It's pretty important.
Yeah.
Are you guys ready for Dixie Week? It is Dixie Week. I know. Are you guys ready for it? Yeah, I've been ready since yesterday. I think the blood has not. Watch out, pictures. That sounds like a T1. Because these ones can be placed.
Because they can turn still several
You
times.
gotta have one Tetris. You have four little squares.
Off at 7:05.
How do those four
Dixie's
squares
feels nice too.
together? You gotta have
Do you guys
every
have
possible
practice?
way that they go together.
I think we
Without
practice
the
tomorrow.
T, you don't have the other.
I think we got practice.
I guess they are important.
Because we're filming it on Friday.
Don't work Fridays. I don't always pick up shifts.
Mr. Officers are gonna try to convince Miss Ron to make it
I'm
shorter.
down to get a Saturday.
Like an hour.
I'm not to get a Saturday.
Well, we'll have Friday. We'll try to.
We watch people.
So, box and whisker, no, don't do that. A box and whisker plot, I'm not going back. Stem and leaf plot. Stem and leaf plot looks like this. I don't know what you want to write down, I wouldn't write down all of this. All a stem and leaf plot does, it separates part of the number off and puts the other numbers over here in numerical order. Some of them won't be in numerical order, that's stupid. It doesn't make any sense to do it that way. So a stem and leaf plot, if I take a number like, on this one, it's got 64. All we're doing is we're making this our stem, and then that's our leaf. So what's this 12 and the 0 represent down here? 120. What's it tell us here about in the 100 range? How many numbers are in that 100 range?
0.
None. And you need those. Even though there's nothing there, you need those numbers there. You still need those stems, even though there's nothing in the leaves part. How many numbers in the 90 range? 4. What are those 4 numbers? 90, 90, 92, and 94. That's all this is telling us. All right, when you make it a stem and leaf plot. And if you turn your head sideways and look at this, it almost looks like one that we covered last time.
Histogram.
Histogram. All right, but you have the numbers all right there. So stem and leaf plot's sort of good. What am I doing? What? No, I forgot to. Sorry. So that's a stem and leaf plot. You separate the numbers. So if I give you a number like 105, got the 10 out here as your stem. You're just gonna put 5 there as your leaf.
Wait, so like, it's not like 105, it's not leftmost and the middle doesn't matter?
It just depends on how you split off your stems, right? So in this case, we split off the stems at the tens column. So 60, 70, 80, 90. Other times this might mean, instead of this way, other times this might mean, and you always have to be given a key, and make sure you put a key on, if you're drawing one, make sure you put a key on it. Maybe next time the key says something like this. 7/2 equals 7.2. And then maybe we're splitting it up at the decimal point, all right? But there should be some key telling you what it means. Next one, it might say something like this. 7/2 equals 0.0072. And then that's telling us that we're splitting it up. This is the tens, hundreds, thousands. We're splitting it up into thousands and the 10,000s. Alright, so you gotta be able to read it, and there should always be a key telling you how to read it. So that's a stem and leaf plot. Nothing really difficult about it. Could we figure out how many numbers are in this set?
Yeah.
What would we have to do? Count all those, tell us how many is in that sample, and then just go from there. What's the lowest number in this sample? 64. What's the highest? 120. Where do most of the numbers fall at? 70s, maybe 70s and 80s, something like that. So we can use that to decide stuff about it. Still the same thing with the stem and leaf plot. Notice I just explained it out here. So 2, 6 tells us 26. There should be some key on this. I didn't put a key on it, so I should probably skip over this. Similar to a histogram, the thing that a histogram doesn't do, that a stem and leaf plot does, it tells you the exact numbers. Constructing a stem and leaf plot, it's not hard. I'm going to skip over this because it's not hard to construct, and we're not going to do this. The following are the numbers of text messages sent last month by cellular phone users on one floor of a college dormitory. Display the data in the stem and leaf plot. Anybody find Ebersole's phone on this? Probably less than that. But since that's the lowest one, that's probably got to be me. Apparently, well, I would say that Phoenix's was higher than that, but he's just playing a game. He ain't sending text messages. He's just playing some silly game all the time. Can't keep his hands off of it for. He was rushing through his quiz just so he could
Keep it in his pocket.
play his game. So if we were going to do this, find the highest, the lowest, split it up, where would we probably split these up at? Probably 10. So we probably make this, if we were doing 155, 15 would be the stem, and 5 would be the leaf. Usually you only want one number in the leaf side of each one. So if we drew it, it'd look something like this. Again, this one says unordered. Don't do that. Doesn't make any sense if it's unordered to even have a stem and leaf plot. Alright? Put them in order. Numerical order as we go out through them. An outlier. An outlier is a number that, numbers, sorry, I thought maybe my English wasn't good there. Numbers that don't fit the rest of the data. What was an outlier on that stem and leaf plot we were looking at? 78. And what was an outlier on the first one that we looked at? 120. Those are outliers. Later on in the year, we'll learn a formula to decide when something is an outlier or not. All right, for now, you're just going to look at it and say, hey, this number's way out here and everything else is over here. Doesn't really fit with the rest of the data. A dot plot. Dot plots are real hard. If I was writing this down, I would write dot plot, and I wouldn't draw that whole picture. Just draw a number line and put some dots on it. So we got a number line. We'll call this 2, 3, 4, 5, 6. And then this one has a dot, another dot, another dot. This one has 1 dot. This one's got 2 dots. That one's got a dot. This one's got 5 dots or something. Who knows? That's a dot plot. You're just putting 1 dot for each item that falls on that certain thing. Nothing hard about dot plots. What 2 numbers occur the most on this dot plot? 25 and 36. What's the highest thing on this dot plot? 45. What's the lowest? 21. Those are dot plots. That's a dot plot. You're just putting a dot. And again, if I do this, it looks like a what? Looks like a histogram. If I could draw very well.
They just follow like histograms.
Yeah, sort of. I mean, histogram's a pretty good thing. Again, this one tells us though each number. Would we want to do this for something where we have like 100 numbers? Probably not. So that's a dot plot, nothing really hard about it, be able to read it, be able to make a list from it. So with like this, I probably won't ask you to make a dot plot for something with this many numbers, that's a lot of numbers. Especially if they're spread apart like these are. So we go clear from 70 to 160, makes our number line huge, a little crazy. What do we know about this 79 right here? You guys told me that earlier, right? And again, if we did something like this, we could sort of make it look like a histogram. That's what a dot plot looks like. Pie chart, forgot about pie chart at the beginning. Pie chart is a circle divided into sectors that represent categories. Remember the circle's 360 degrees. Remember all the stuff that I taught you in geometry about central angles and stuff, if I had you in geometry. If I didn't, hopefully your teacher taught it to you. Central angles, remember a central angle just is an angle that has its vertex at the center. You're going to have to split up these pie charts perfectly. Some things I want you to remember with a pie chart. If we put a 90-degree angle in here, what part of the pie is that? 1/4. So as a percentage, normally we would put in percents. As a percentage, what is that? So if we're making a pie chart, base stuff off of 1/4 of the pie. If it's half the pie, how much is it? 50%. Base stuff off of that. So if I had something like 1/10 of the pie, I'd look at this and I'd say, okay, that's 1/4 of the pie. I only want 1/10 of it, so yeah, maybe something like that. And that would be about 10%. That'd probably be a little more than that. About like that there. We're not going to be exact, but it should be close. So if I tell you to make a pie chart and you do something like this, and you put 10% in that, yeah, probably not.
That's 10%.
6 pies. Alright, so with the pie charts, remember the 360 degrees. So if they tell you something like it's 30 degrees and you want to change it to a percent to see what it is, 30 divided by 360, you find that decimal, change it to a percent, and then we can base everything off that 50, 25, so on and so on. Make things easy on yourself. Again, we're not going to make pie charts that are perfect. We're not doing that in this class. Somebody do me a favor and numbers are in degrees and then have it. Yeah, let's not do that. Just looking at this, if we added these up, that's 2,200, 2,800, about 3,000. There's about 3,000 people there. Somebody grab your calculator and help me out. What's 728 divided by 3,000?
4%.
So it's almost 25%, isn't it? So if we were going to make a pie chart for this, associate's degree, oops, 24%. I would make it about like that right there, cut off about 1/4 of the pie, and then go from there. What do you notice about this? It's about double the 728, isn't it? Probably somewhere closer. So it's probably here, and I put bachelor's degree here and put the percentage in there with it. Then the rest of them, the 604 is not quite 728, but it's going to be quite a bit of that, this part. So that's going to be the master's. And then these other two parts, little pieces are gonna be split up. That right there is a good pie chart for this one. And, well, with everything written in it. Constructing a pie chart, I just showed you how to do that, it's nothing hard. Divide it all out, that was 51%, 24%, 20%, 3% and 2%, very small parts of the pie. That's what I would give you guys if we were, if we had a pie in here to share, you get the 3 or the 2% gauge. You can tell, ain't sharing much. That's, so looks something like that, does that look about like what mine did? Yeah, it's pretty close, just sideways. We just did that way. Never mind. Pareto chart. Pareto chart. Well, a few times, you got some idiots in math, just like you have in other things. Usually, I say math people don't name stuff, you know, with stupid names. Well, Pareto was a mathematician, and he was an idiot and had to name something after himself. That's science that does that crap, not math. Pythagorean's theorem, he was an idiot too. Name stuff after yourself. Make it math. Pareto chart is a bar chart, but in the bar chart, the bars can or may not touch. But the one thing that the bars always do is they go in order. So they always start at the biggest and go down to the smallest. That's a Pareto chart. Always starts with the biggest bar, goes down to the smallest. Pareto was probably a business person, and he was trying to get poor Brendan there fired, and so he put the bars biggest to smallest, because as soon as you see that, what do you think of? Things are going down. Doesn't necessarily mean that, because we move the bars around so they go biggest to smallest. That's what a Pareto chart does. Always goes from the biggest, tallest bar to the smallest bar. Frequency on the side, whatever the categories are on the bottom. It could be classes, it could be like freshmen, sophomores, juniors, seniors, whatever's along the bottom. Constructing a Pareto chart, you just construct a bar chart and then put them biggest to smallest. There's nothing hard about that. I'll skip over that quite a bit. We're not doing this example. So that's a Pareto chart. Gauge, anything too hard so far today?
Not today.
Paired data sets. This is also called a scatter plot. You got your points and you're just scattering them around all over there. Hopefully in some of your other classes, you've learned that even though it's a scatter plot, is there some line that probably fits that set of data? Yeah, and that's called the line of best fit. We're probably not going to deal with the line of best fit, but we might deal with the line of fit. So, line of best fit takes a lot to figure out what it is. Alright? So in other math classes, if you found the line of best fit, you probably didn't. You probably found the line that just sort of fit it. Alright? Line of best fit, what you have to do is you have to take the average of all of them and then subtract off each point separately and find all of those differences, add all those differences up, find that middle point, and then go from there, and it's a big, long, drawn-out thing. Your calculators will actually do it, but it's almost as hard on the calculator as it is doing it out longhand. Pain in the butt. When you're doing something like this, the one that I use all the time, when you somebody has a baby. What two things do they measure on a baby? Weight, height. So when they measure the weight and height, maybe the weight's down here, the height's over here, and then they go on this scatter plot, and they put the baby on there somewhere, all right? And what they do with that then, there's a line of best fit, that's where the baby should fall at. All right? So if this is the line of best fit, and you have a baby that's like right here, something's not right probably. All right? Or if you have a baby who, now, let's just go with that one. That means their weight is way out here, and their height is way down here. What's that telling you about your baby? Probably fat. Too fat, right? It's probably, the doctor's gonna say, hey, I'm not sure what you're doing, but you're not feeding this baby the right way. It could be with animals too. You go to the vet, they have the same kind of setup. If I was to take one of our cats in there, our cat's a great big huge fat thing, because all it does is sit around. They'd probably say, hey, your cat's too fat, something's not right here. It's gonna die soon, and I would probably say.
You don't like your cat?
I don't like either one of them, they don't like me either.
Your dog's fat?
They hiss at you?
Seen Bernard?
No, they don't hiss at me, they just run. They won't let me get close to them. Well, unless I walk close to them, then they run.
Bernard watches how they stay on.
So scatter plot might look something like this. If we tried to draw in a line of fit on this, and if we do lines of fit when we get to that, I'll probably just have you draw something like this. Then we can sort of estimate off of that what it is. So if I say the petal length is about 50, what can you tell me about the width? Could you find what the width probably should be close to? You're just going up to about there. What's the petal width gonna be? Maybe 17, somewhere around there. And you can interpret off of that. What do you think happened here? Almost looks like if we're doing something with some iris, then it almost looks like maybe we're doing two different kinds of irises or something. And maybe the one type falls down in this range and the other type is up here or something. Be able to interpret that stuff. Try to, use your brain to come up with something. Time series. Time series is paired data, and it's just what the name says. The horizontal axis is always going to be time. The horizontal axis is always time, whether it's years, 1999, 2000, 2001, so on and so on. Or it could be January, February, March, April, May, or it could be January 1st, January 2nd, January 3rd, whatever. But the horizontal axis is always time. And all you're doing with it, when you're making your graph, your time's here, and you're just saying, all right, at January 1st, we were here. At January 2nd, we were here. At January 3rd, we were here. At January 4th, we were here. January 5th, we were here. And you're just connecting it. That's a time series. Time along the bottom, and whatever the frequency or whatever you're dealing with along the side. Number of screens at drive-in movie theaters. Anybody know what a drive-in movie theater is? So what's been happening to drive-in movie theaters since back in the Stone Age when Ebersole was young and there was still actually drive-in movie theaters around?
They're less popular.
They're less popular, and there's a whole bunch fewer of them. So way back in 1987, I was in college by that time, there was this many in the United States, and what happened to them?
Gone down.
Started going way down, and probably now, we're way out here, 2022. You think we went up or down from there? Probably went down a little more, but it's starting to level off because they're sort of starting to make a little bit of a comeback, but there's not near as many of them. But they're not shutting down as quick as they once did. Must did something with gas, the gas prices and stuff, one of the times. I don't remember what it was now. Cellular phone subscribers, what's happened since 1998?
Going up.
It's went way up, it's probably, now it's probably even going up a little quicker, cause 2008, you didn't see very many 10-year-olds running around with a cell phone. Now, every single one of them's got one, except for my kids. They were that young, they weren't getting a cell phone when they were young. That's it. That's the assignment.